And here we're talking about HVAC, heating, ventilation, and air conditioning. What you see represented here is residential HVAC. What I'm going to speak about also applies to industrial and commercial HVAC. And this is a very big problem, part of the global concern over greenhouse gas emissions. Why? Because globally, about 30% of the electric power usage is in HVAC, and also a substantial portion of the total greenhouse gas emissions. So again, we're talking about the past and the present in the system domain. Here we have what represents 36,000 BTUs, the good cooling and heating standard for residential. And this is done by electrically powered air conditioning and a gas furnace. So as we know, legislation already going into place to eliminate these. This is an obvious contributor to greenhouse gases, and it's quite inefficient and also has a very high footprint in life cycle, meaning all of the material it takes to manufacture it and the energy that goes into the manufacturing, in addition to the efficiency throughout its lifetime. On the other side, we have a heat pump. So it's a much more efficient cooling methodology. It's about twice as efficient, and it also represents the same 36,000 BTUs. You can also see a significant decrease in the amount of material and energy that goes into manufacturing it, in addition to the lifetime energy use, which is about half in terms of the electric power. Also, what's the effect on CO2 emissions globally? It's down by about 60% with the heat pump. All of this applies, and GaN and silicon carbide, does that affect, how does it benefit HVAC? By efficiency and also by increased switching frequency for the motor drive. All of this applies also at a silicon carbide level and higher power to industrial and commercial systems. And next we'll talk about solar energy and renewables.